Okay, so in this video, we will solve problem 9D from problem sheet number 5. And the question is to count all possible hands of 5 cards when the cards are being dealt from a regular deck of 52 cards. So all possible hands of 5 cards that contain exactly 2 pairs. And when we say 2 pairs, we mean not a pair and a triple, 2 distinct pair and a distinct 5th card. So again, we have the cards here laid out according to their suits: hearts, diamonds, clubs, and spades, and then according to their kinds: aces, kings, queens, jacks, tens, down to twos. And we've put the aces first, thinking of a hand of poker, so the ace being the strongest card. So we have 4 suits times 13 kinds for a total of 52 cards. The cards are dealt randomly from the deck of 52 cards. When you get your 5 cards, you can shuffle them any way you want. It's still the same hand of 5 cards. And once a card is being dealt, it cannot be dealt again. So clearly here we have a setup that is without replacement and unordered. So we can use our knowledge of combinations, NCR. Well, let us remind ourselves first of how many such possible hands of 5 cards are there. Well, out of the 52 possible cards, we choose 5 at random, which gives us a total of 2,598,960 different possible hands of 5 cards. About 2.6 million hands of 5 cards in total, distinct hands of 5 cards. And out of those, we want to count only those that contain exactly 2 distinct pairs. Again, we're going to go with a specific example and work from the example to the general problem. So we are dealt 5 cards at random. We need 2 distinct pairs and then the 5th card. So again, let's pick an actual example. Say we have as our first pair a pair of jacks. Then say we have a pair of 4s. Now we're missing the suit, right? The 2 jacks. Well, which suit are they from? Is it a jack of hearts, jack of clubs, jack of diamonds, jack of spades? Let's pick 2 at random. Say we have a jack of diamonds and a jack of spades. For the 4s, say we have a 4 of clubs and a 4 of diamonds. We're missing now the 5th card, and again we have to be careful here, right? We said exactly 2 pairs. So the 5th card can't be a 4 nor a jack. This would give us a triple of 4 or a triple of jacks. We don't want this. So let's pick a 5th card different from 4s and jacks. Say it's a king. King of what? Say a king of spades. So now we have such a hand. 5 cards, 2 distinct pairs, and a 5th card. So let's try and then count. Now we only have 1 such hand. Let's not try to count all possible such hands. Well, the first thing we do is choosing the kinds of our 2 pairs, right? Is it a pair of jacks and a pair of 4s? Is it a pair of king, a pair of 3s? Is it a pair of 5s, a pair of 6s? Well, let's ask again, what's the setup here? Clearly it's unordered, right? If I swap these 2 pairs, if I say I have a pair of jacks, then a pair of 4s, or a pair of 4s, pair of jacks, it's still the same hand. So when we choose the kind for the 2 pairs, that is unordered and also without replacement. They have to be distinct pairs. So again, we can use our combinations. How many kinds can we choose from? 13 kinds in total. And out of those 13 kinds, we choose two distinct kinds. First kind for the first pair, second kind for the second. 13, choose 2. Whoops. Choose 2, not 3. So 13, choose 2. But this only now chooses the kinds, right? If I say to you, out of those 13 kinds, we choose 2. So say we choose the jacks and the 4s. Well, we're not done, right? Because you say, well, out of the 4 jacks, which 2 did you choose, right? How many pairs of jacks are there? Well, out of the 4 available jacks, we chose 2. So there are 4 C2 ways of choosing out of the 4 available jacks, 2 of them. So there are that many distinct pairs of jacks. The same is true for the pair of 4s, right? There are 4 4s to choose from, and out of those 4 available cards, we choose 2 again. So there are 4 C2 different ways of choosing the second pair. Now we have chosen our 2 pairs. We've chosen the kinds, jacks, 4s, chosen the suit of the first pair. Out of the 4 available jacks, we chose 2, and chosen the suit of the second pair. Out of the 4 available 4s, we chose 2. We chose the suit of the second pair. We're now missing the 5th card. Well, how many cards are there left over to choose from for the 5th card? Well, there were in total initially 52 cards, minus the ones that have to be ruled out. And be careful here, it's not minus 4, right? Yes, we have 4 cards now in our deck, but we have to rule out more than this, because the 5th card, as we've said, cannot be a jack again, or a 4. This would lead to a triple, and we only want 2 pairs. 2 distinct pairs, nothing stronger. So we have to avoid a triple, which means we have to rule out the 2 kinds that we initially chose from for the 2 distinct pairs. So the jacks are out, minus 4 cards. And the 4s are out, minus 4 cards again. So we have to rule out 8 cards to guarantee that we will not get a triple. And this leaves us with the cards left over that will be distinct from either of the 2 pairs. We can simplify this a little bit. 13 choose 2, we'll leave it at that. 4 choose 2 times 4 choose 2. We can simplify as 4 choose 2 squared, and 52 minus 8. 44 options again for the 5th card. After ruling all the jacks, 4 cards, and all the 4s, 4 more cards, 8 cards in total. This leaves us with the cards left over that will give us a distinct card from our initial 2 distinct pairs. And if you calculate this, you can of course use a calculator. You will find 123,552. So out of roughly 2.6 million total possible hands of 5 cards, about 120,000 of those will contain exactly 2 distinct pairs and nothing stronger.